Hello everyone, this is the last video in the lipid series of videos, and this is going to be looking at oxidative rancidity, or trying to explain the process behind lipid going rancid, usually for unsaturated fat. Alright, so rancidity and rancidification, another very nice word that you can use if you want to impress people. So rancidification is a process by which unsaturated lipid oxidize, nice word again, and break down and produce harmful chemicals. So rancidification, or when you say a lipid or an oil has gone rancid, essentially a lot of it has been broken down into smaller molecules, and a lot of those smaller molecules are harmful, usually in the form of short chain aldehydes and ketones. So you get some aldehyde and ketones being produced as the result of this breakdown process. This is usually detected via a deterioration in smell and taste of the lipid. So if it smells bad, if it smells bad, don't taste it, but it also will probably taste quite bad. Sometimes. Sometimes that's actually the desired taste. I'll talk about that later. Rancidification generally happens due to the reactive nature of the carbon-carbon double bonds in the fatty acid chains. So you usually don't have rancidification. I suppose in theory it could happen. It's just a lot harder. It's quite hard for saturated lipid to go rancid compared to unsaturated. So I would just say here mainly unsaturated lipid will go rancid. The CC double bond definitely makes it going rancid a lot more easily because the area around the CC double bond would be a little bit more reactive than the carbon-carbon single bond. So in general, the more unsaturated the lipid, the more likely or quickly it can go rancid. Now, so rancidity is the nature of the oil, and rancidification is the process by which that happens. We're going to look at specifically oxidative rancidity, which is a type of rancidification in which the breakdown happens via a reaction with oxygen gas, so O2. There are other types of rancidity, but we're just going to look at oxidative rancidity for this course. And the last thing about rancidity that you want to be aware of, and I'll go through a specific example, is that rancidity is a chain reaction. So it involves the formation of free radicals. I really wish we would have the time to go into chain reactions a little bit more. It is very interesting, but unfortunately we won't. I don't know whether they cover this in physics, chain reaction with free radicals, but I'll just go through the one example. So this is just some of the really basic things that you need to know about rancidity. All right, so I will give you an example of oxidative rancidity chain reaction. I really can't write things these days. That's supposed to say oxidative rancidity chain reaction. All right, so I'm going to abbreviate a fatty acid as RH. So essentially, I just have the whole fatty acid chain. I know that it has a carboxyl group, but I'm just going to show everything and then a hydrogen, okay? So just going to say that's a fatty acid. And all you need to think about is that this fatty acid, the R and the H, is going to form a covalent bond between them. So share pair of electrons in the middle there. So that's that. The first thing that will happen with oxidative rancidity is a process called initiation. So the reaction starts. Initiation happens when a radical is formed, and this is normally as a result of a reaction with sunlight, heat, mainly those two. Sometimes it just randomly becomes rancid because it can. Probably a good position to define what a free radical is, because I don't think I've done this before. So a free radical is a molecule or atom with an unpaired outer shell electron. Even though I haven't really defined it, you actually have seen free radicals when we look at mass spectrometry. So the fragments that you get, well, the one that's non-positively charged, essentially could be a free radical. So this unpaired electron is usually represented by a dot in the formula. So it just has an unpaired outer shell electron. So what happened with the initiation step is that the fatty acid molecule, and this could happen within the oil, so the fatty acid chain in the oil, randomly gets broken down into two free radicals, as you can see here. So the first one is R, the free radical R, and then the second is just a random hydrogen atom. So this is a hydrogen atom with an unpaired electron, which is essentially a normal hydrogen atom, which is considered a free radical because you normally wouldn't see it. So initiation. Now, what happened next is that this free radical that is just formed is going to go and react with oxygen in the air, hence the name oxidative rancidity. And this free radical is going to basically, I'm not going to go into too much details, but the free radical is just going to attach the two oxygen atoms to it. So now you have another free radical, which is ROO dot. Okay, so you go from R dot free radical to ROO dot, another free radical. This second free radical is a little bit more reactive because of the presence of oxygen. And this is where it gets really interesting. This second free radical that you just form with oxygen is now going to attack a normal fatty acid. So this is fatty acid 1 that has been degraded and turned into free radicals. This free radical would then go and react with oxygen, and the product of that is now going to go and attack fatty acid 2. So this is where the chain comes in, because you start with one and then it's going to make something that can go and attack another one. And you can see how after this, you reform R dot. So R dot can go again and form another molecule, another free radical with oxygen. And then that is going to go and then attack another normal fatty acid. So you go from 1 to 2 to 3 to 4 to 5 until you have a lot of fatty acids being broken down into free radicals. Okay, so it's not that, well, it's not really that these two are going in a loop. It's just that you're just going to keep attacking new fatty acids if this process continue. So this is actually called the propagation of a chain reaction. So it's when the radical attacks other molecules and continually forming more free radicals. So you keep having more and more free radical as the result of that, which is not good. Now, the problem with free radicals is that they are very unstable and they would go and attack other molecules for the extra electrons, because remember that they have an unpaired outer shell electron. So they're going to go and try to get that extra electron. So essentially, they're trying to go and undergo reduction, if you will. Usually, what happens that they go and cleave certain areas of proteins or DNA, so it causes a lot of damage to the cell if free radicals are present. Another thing that will happen is that the ROOH that is formed generally get broken down into aldehydes and ketones, and it also forms some other free radicals. And these particular products, so the aldehydes and ketones that are formed from ROOH, is the cause of the bad taste and smell. So the bad taste and smell are not necessarily because of the free radicals, but it is an indication that free radicals would also be present if you can taste or smell the things from aldehyde and ketone in a natural process. So this can keep happening, and then once one fatty acid is broken down, you can have a lot of fatty acids consequently get broken down and a lot more free radicals being formed, which means that the oil can no longer be used at this point. This is another diagram that summarizes the process if you want to use it. I mean, it talks a little bit about the last step, which is termination. And this can happen if two radicals combine, so they both happy and reform the covalent bond. It is, however, quite difficult to make sure that they meet, though, in the cell. And a lot of the time, they just attack the first thing that they can see. I also have a few examples of some of the aldehydes or ketones that can be formed via the breakdown, and you can see here that they can have different smell. I think somebody told me no two rancid oil smell the same, but I'm like, I don't really want to smell rancid oil. However, fun fact, they actually try to achieve this molecule because one of them has a cheesy smell. So in some scenarios, you actually kind of want this smell, especially in like the aging of cheese. You obviously don't do it via letting oil go off and producing free radicals, but in some cases, these very distinct smells can be desirable for the certain food product. Now, what we really need to discuss though is how do we prevent or limit rancidity? So, how do you sort of minimize the oil coming up? So, if you think about this whole process, the first thing that you can do is you want to prevent the first step from happening. So, you don't want the fatty acid to randomly break down into free radicals in the first place. Now, there's no way that you can guarantee that, which is why when you go to the shop, oil tends to have an expiration date because if you leave it for long enough, a lot of things can happen. But if you want to, if you remove it from sunlight or heat, then that generally makes it a little bit safer. So you removing the oil from an environment that promotes initiation of producing free radicals. So you really don't want to store your oil near the stove. You should put it in a pantry, and I don't think you should store oil in a clear bottles if you can help it. I would say try to go for like a more tinted glass if you can. I mean, if you buy the oil from like Coles, which is like a plastic clear bottle, then make sure that it's in the pantry so it's away from sunlight or heat, which tends to promote in this breakdown of the oil over time. So let's say you get to this point and you can't prevent the first step, then the next thing that you can try to do is you want to prevent the second step. I mean, you can preserve a lot of things if you remove oxygen from it. I think that's just a fact. So if you can make sure you put the lid on the oil and or that is vacuum sealed or that there's not a lot of oxygen available in the oil, that also will slow down the process of rancidity. You can't ever completely remove oxygen, but you can try to minimize contact with oxygen. So these are some of the methods to prevent or limit rancidity. The first one, you can store it away from sunlight and heat. You can remove water as well. Water is, this is not really the rancidity that we're looking at, but water reacts with a lot of things. I'm sure you know by now. So it can also cause rancidity. You can vacuum seal to try to remove oxygen as much as possible. I don't think anyone has done this, but you can put the oil in the fridge, which will slow down the process of rancidity. Just like anything else, it slows down the reaction rate, but you cannot completely prevent rancidity. I suppose we will put things like fish in the fridge because there's a lot of unsaturated oil in fish or seafood in general. So that's one of the reasons why it goes off a lot more quickly than, let's say, meat. So I suppose you don't put oil in the fridge, but you put, raw meat products in the fridge. The last way now, this probably is more things that you eat, so you can't really. It's not you're not really stopping the oil from coming up. You're trying to stop the effect of the free radicals on your body. Let's suppose you already consume a product that has some lipid that has gone rancid. Then what you can do is to use antioxidants. You should eat a lot of food with antioxidants in anyway, and the reason for that is because an antioxidant is essentially any molecules that donate electrons to free radicals. So I have two diagrams here. I really like this one though. So antioxidant is just, a roundabout way of saying reductant or reducing agent. And I'm sure you remember, a reducing agent is something that undergoes oxidation, so it will lose electrons. So reducing agent. So antioxidants donate electrons to free radicals, and these prevent them from attacking other molecules. They usually do not. So they usually do not prevent the initiation step, but they do interrupt the propagation sometimes, especially if the process does happen in your body, and so it can neutralize some of these free radicals. So consuming antioxidant is another way to minimize the impact of rancid oil. Just for your information, here are some naturally occurring antioxidants. I just say eat a lot of berries is probably a good idea, but you can find antioxidants in other food as well. Now, vitamin C is an antioxidant, vitamin E also, and there are some synthetic antioxidants. So what I'm trying to get at with this slide is just that there are a lot of different types of antioxidants, and unfortunately, we don't look at the specific chemical reactions of any one of them because they do react in different ways slightly. I mean, they all donate electrons. That's pretty much the only thing they have in common, but they can be synthetic or naturally occurring. This is something I got from the textbook, which you can read it yourself. It's in chapter 16 of the textbook. And it basically talks about how a lot of imported oil is not very well regulated. So a lot of it has gone rancid by the time it reaches Australia. So you want to be quite careful when you buy imported oil. Whereas Australian oil performed quite well in terms of not being rancid. But yeah, and it talks about how it could be because the oil has been stored for a very long time, especially if it's imported from overseas. And it is very hard to regulate if it's imported. So just be careful when you buy your oil product. And that is all for this dot point. Thank you.